Okay, gonna try this again with some better lighting. Got everything out of the box for the Sable 2015, and now I'm gonna describe all the stuff I found in the box. It's the only instruction sheet you get. Parallel port diagram for the controller itself, and some jumper settings down here. I ain't figured out what those mean yet. Diagram of the output on the power supply. Yeah, good lighting, eh? Let's try that again. Complimentary blank piece of paper. And some specs for the stepper motors. 4.4 kilogram centimeters for 2 phases holding on, 1.8 degree step angle, 5%, 1.65 ohms phase resistance, 2 phase, and some measurements. Metric, of course. Power supply here, set it for 120. The output that goes to the controller itself. It's like a typical power supply. 110, 120 in, 24 volt, 5 amp out. Looks pretty decent. Yeah. This may as well be Klingon to me. Parallel port cable. How's that lighting working, eh? Cables for the stepper motors. Again, they look pretty good. Yeah, good enough. The mill motor itself, like I was saying before, pretty good and tight here. Feels pretty good. 25,000 RPM, 210 watts. Beefy piece. I have no idea what that is. I think it's a bead of some sort. Might be a fuse. I'll open it up someday and check it out. Empty bag. The mill mount extension plate for the Z-axis. How's that lighting working? Comes with the hardware. Mill mount itself with hardware. Chuck for the mill. And the controller. Big old heatsink. 3 driver chips. They got heatsink compound on them. 3 outputs, XYZ or ZYX, one of the 3, whatever. Power supply input. Yeah. Yeah, a jumper block up front here. Don't know what they're for though. And let's see. Oh, that TI chip. That's a 555. Don't know what a lot of this stuff is for. The directions just aren't that specific. Got a breakout over here. Looks like you can plug in a bunch of like your limit switches. Yeah, your enables, your limit switches. P-set 11, 12, 13, and 15. Got no idea what that means. 4-axis step, 4-axis direction. It must be the 4th axis. Spindle extend. I don't know if that's an on or an off or what. No idea. Anyways, on the meat. The actual machine itself, the actual assembly. Yeah, that's what I'm talking about. You got your Z-axis motor here. Everything's got, I forget what the pitch and the pitch is on these lead screws. I want to say it's 1.5 by 10 metric. Solid coupler. I don't know if I like that. I've seen a lot of guys go with, or read of a lot of guys going with the rubber coupling. Keep the vibration down, I suppose. I don't know. Bearings here, nice snap rings. Looks like you can replace them if you need to. That motor mount extension bolts up here. The mill motor bolts up the front right about here. You know, goes up and down. Here's the plate. The X-axis motor. Rubber seat on there, linear bearings. Yeah, a lot of grease on that. Everything's held together with Allen wrenches. Got rubber bumps on the bottom. Solid chunk of aluminum. Y-axis motor. It's a beefy piece of equipment. And again, I can't detect any play in anything here. Doesn't mean it's not measurable, but at least I can't detect it. All your connectors for your motors. Grease on my hands already. Jeez. Yeah. There's the back of it. I suppose I'll go through and tighten up all the bolts and nuts and whatnot before I try to use it. Yep. I suppose the next step would be trying to find a computer that can run the thing, because the laptop I was going to use got too much latency according to latency-test on Ubuntu 8.04 on the Linux CNC machine. Can't use that. The latency is something like 113,000 or something like that, and it spikes up to 16 million, way too much. It's supposed to have something like less than 10,000 nanoseconds, 10 microseconds latency. I don't know if that means I gotta go with my desktop or what, but I'll figure it out later.